Now, up to this point, if somebody walked up to us and said, hey, what's the primary difference between a standard access control list and an extended one, we could say with confidence, the standard access list can only match based on source IP address. That's it, nothing else. And the extended access control list can match on virtually everything else, including that. So source and destination for both layer 3 IP address information and layer 4 information like TCP and UDP and ports and so forth. So in this lab, here's what I'd like to do. Let's take the plan that we formulated in the previous video. We'll review it together, and then we'll go to the CLI to apply the extended access control list and verify that it works. So here's our goal. We're going to make a 3-entry extended access control list. And if we're going to use a numbered access list, it's going to be from 100 through 199. There are some other options, including names, but we're going to start by creating an access list 100 with these 3 entries. One that denies ICMP from .10 going to .100, an entry that denies TCP traffic from .10 going to .100 if the destination port is 80, and then we're going to permit everything else on the 3rd line. So let's jump into the hands-on lab, and I'll walk you through the syntax step by step. And I suppose before we implement the access control list, let's also verify that we have basic connectivity from the client PC through router 1. So to do that, let's bring up a command prompt on the Windows computer, the Windows client. Any way you want to bring up a command prompt is fine. And we'll do a IP config, just verify our IP address, 10.16.0.10, fantastic. And let's do a ping out to 192.168.1.100. That works, that's great. And let's also verify web services work. So we can open up a browser. There's Chrome on the desktop. We'll double click that. And we'll go to 192.168.1.100, press enter. That works. So fantastic. So at the moment, web services with TCP port 80 work, and also ICMP works based on what we just tested. Great. Let's go to DCNUG, our admin computer. We'll authenticate, and we'll open up PuTTY in the upper left-hand corner. And on the servers tab, we'll open up a connection to router 1. So here in router 1, we'll do a config T. In fact, let's just do this right. We definitely want to make sure that we verify what access control lists are in place before we start configuring. That way we avoid adding on to an existing access control list and getting really weird results. So let's do a show access lists. And there's no access list. That's great. I've reset the lab. And let's go into configuration mode and create an extended access list number 100. And although there's many ways of doing it, let's do it this way. Access list, space, use a question mark, and let's use 100 space, and let's go ahead and do our deny. And if you look at our plan is to deny ICMP from .10 to .100, so let's do that one first. So let's use a question mark, and you'll notice we have a lot of options here as far as what we want to match on. And what we want to match on is ICMP. We're going to deny ICMP, and then the syntax is source information first, followed by destination information. So if we use the question mark again, now it's asking us for the source address. And the source address is going to be host space to represent all 32 bits of what follows 10.16.0.10. Now, if we wanted to use wildcard masks too for a range, just like we did with the standard access list, we could. We could specify a network and a combination of wildcard bits to specify a range of addresses. So now that we put in the keyword host to mean all 32 bits of the following IP address, space, now we're going to add the destination information. So the destination, because it's one specific host, we can use the keyword of host and then specify the IP address of 192.168.1.100. Or this would also work. We could put in the address of 192.168.1.100. And then my question would be, what would be the wildcard bits that we could use right here that would mean we care about matching on all 32 bits of that 192.168.1.100? What would a wildcard mask look like to say we care about matching all those bits? And if we say, well, we care about all of them, so all the wildcard bits are going to be off. We use 0, 0, 0, 0. That would work. So the keyword host followed by the IP address, or the IP address followed by 4 zeros for the wildcard mask, mean exactly the same thing to the router for this entry in the access control list. We'll do a space, a question mark, and up here we have some options regarding ICMP, looking for echo or echo reply and some other options as well. But what I'm going to do here is I'm just going to add the keyword of log and press enter, and we have now our first line in the access control list. Also right here, what happens on a Cisco router is when your command line or when your line gets too long, it pushes the content over on the left, and that little dollar symbol just means there's more content to your left. So you can do a Control A, go all the way to the beginning, or use the arrow keys to go back if you need to on that command line to see what that is. So that's one entry done. Let's take a look at our next one. So our next one is to deny TCP traffic going from .10 to .100 if the destination port is TCP port 80. All right, let's do it. So the syntax is access list, and we're going to use 100. So this is just adding to this existing access list, and we want to go ahead and deny. And now we're going to specify TCP. So we'll specify TCP as the layer 4 protocol, and the source address of 10.16.0.10, and the destination host at 192.168.1.100 space, check this out. Now we're going to add the parameters for the destination port. And so we're going to specify here EQ, meaning equals, and then I'm going to go ahead and put 80. So what that means in English is denies TCP traffic if it's coming from the source IP address of 10.16.0.10 and it's going to the destination host address of 192.168.1.100 and the destination port is exactly 80, which is the well-known port for HTTP. And we'll press enter. And then we need one last line to permit everything else. And that's also based on our plan. So we'll add the third entry to permit everything else that didn't match either of those two previous denies. So to do that, we'll do access list, 100, permit IP, which is a catch-all, and we'll say any for the source and any for the destination, just like that. And that allows all other traffic that wasn't previously matched in this access control list. And then we need to apply it to the gig 00 interface. So interface gig 0/0 here on R1 and IP access group 100. And we'll apply this inbound as any traffic is trying to come into this router on that interface and press enter. Then we'll go ahead and do a show IP access list. And we can also do a show access list. Both those commands are going to give us the information we need, which also implies that there's other access list types besides just IPv4. So as we take a look at this access list with these three entries, sequence number 10, 20, and 30, notice that when we said equals 80, it automatically just put www there. That's a shortcut or a keyword that represents port 80. So let's go to our client and let's try a ping to 192.168.1.100. That should be denied and logged. And let's also go ahead and open up a web browser from our PC to that web server. And we should get some hits on that as those packets are denied. And there we go. There's our first traffic that's been denied. So this traffic was ICMP from that host going to 192.168.1.100. So let's go back to that host and check it out. And I left those windows open. Okay. So on this PC, let's go ahead and do a ping. So that should fail. R1 is killing it. And if we open up a browser, and hopefully a browser that doesn't have anything cached, I'm going to go ahead and click on the Windows icon and just type in Internet, because Internet Explorer has not been used on this system, so there won't be any caching going on there. And let's put in the destination of 192.168.1.100, and that should fail because we're blocking on that match TCP traffic from this PC's IP address to the server's IP address if the destination port is 80 and it matches, and as a result it's not making it through. All right, let's close that browser as well. Close all the tabs. In fact, let's do one more thing. Let's open up Google Chrome on the desktop here, and let's go to FTP, and we'll do FTP : whack 192.168.1.100 because there is FTP services running on that, and that is not going to be using destination port 80. So this theoretically should work from this client. So we'll go to FTP 192.168.1.100, and the crowd goes wild. Let's go back to DCNUG. Let's take a look at our access list hit counts, and that'll help reinforce that it's working as expected. So we'll go back to DCNUG, and we'll do a show access lists. And sure enough, so for ICMP, we have 12 matches. For TCP trying to get to port 80, we have 3 matches. And for the permitting everything else, we have 216 matches, which would have included our FTP traffic. So IP extended access lists have a lot of options that we can put in them. Now the secret I found is that start simple, meaning in this lab where I walked you through a specific example with just a 3-entry, 3-row access control list that we applied and verified, please do that. Practice using that exact same syntax. Walk it through, use this lab, use LiveGear, use Viral, whatever you want to use, but get that practice and start with the basics. And then as you get better and more familiar with access control lists, we can start to use them more and more where needed in production to control traffic the way we need to on our networks. So thanks for joining me in this video in lab, and I'll see you in the next one. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.